Okay, the second video for today is on soap and its cleansing action. All right. Now, the first thing we need to know is to prepare soap or to manufacture soap, the process is called saponification. Okay, the process is called saponification process. Now, saponification process is to make soap, and this process happens when the ester, which we learned in our two classes previous class, ester linkage is broken to form glycerol and soap. Okay, so saponification process is also called the hydrolysis reaction. So in some books you may see the word they use is hydrolysis reaction. It is the same as saponification process. Basically, in saponification process, the reaction that occurs is hydrolysis reaction. Okay, this is basically a reverse reaction of esterification, which we learned as well. So let's look at how saponification process occurs. Now, first thing is to make soap. Okay, to produce soap, we need a natural ester. Okay, we need a natural ester, and we have learned natural esters can consist of things like palm oil, okay, or olive oil, okay, any vegetable or plant-based oils, olive oil, or it can also be coconut oil. All right. Okay, alkaline basically two types are used for this process, either sodium hydroxide or potassium hydroxide. Right, so either one, not both, either one, sodium hydroxide, SO, sodium hydroxide or potassium hydroxide. All right, so the natural ester as we listed can be palm oil or olive oil, coconut oil, any plant-based oil. Now if you look at natural ester, okay, just to recap back, natural ester. Now natural ester can be broken into two parts. One is fatty acid. Okay, so actually what we require to make soap is the fatty acid section, because the soap is actually going to be the fatty acid salt. It's a salt which is based on the fatty acid, and the fatty acid is actually coming from the natural ester. Okay, so one of the component of natural ester is fatty acid. The other component of natural ester is this thing called glycerol. Okay, glycerol. Now glycerol, see here, glycerol is basically a kind of alcohol. Okay, it's a kind of alcohol, but it's called trihydric alcohol. It has 3 OH bonds, but it's sufficient if you remember glycerol. All right, what is glycerol? A kind of alcohol. So this glycerol and fatty acid is the component of natural ester. Okay, so again, coming back to this reaction, saponification process, we need a natural ester. Why? Because we want the fatty acid. Okay, the thing that we require from the natural ester is the fatty acid. All right, because when natural ester decompose, it will become fatty acid plus glycerol, and the fatty acid is the one which is going to combine with the alkaline, either sodium or potassium, to form the fatty acid salt. All right, so here, for example, let's look at an example. Okay, for example, if I have palmitic acid, okay, I'm looking at palm oil. Palm oil, one of the key component is palmitic acid. Okay, palm oil actually contains not only palmitic acid, it contains lauric acid and so on. So one of the component of palm oil is palmitic acid. So if I use palm oil, then it would be mainly palmitic acid as my fatty acid. All right, that's the natural ester which we are talking about. Okay, this is from palm oil. Added with, let's say I choose sodium hydroxide this time. So sodium hydroxide, right? Sodium hydroxide. I would get sodium, okay, from the alkaline sodium, and because it's palmitic, I will get palmitate. Okay, I will get sodium palmitate, plus of course plus with glycerol. Okay, so plus glycerol. So this glycerol is fixed. Whatever you use as the fatty acid or natural ester, or whatever you use as the alkaline, doesn't matter. It's always going to be glycerol at the end. This is the waste product, byproduct. Okay, we're not interested in this. We are interested in the sodium palmitate which forms, because this is actually the soap, okay, which is produced. So remember, natural ester plus alkaline becomes sodium palmitate soap or a fatty acid salt. This is a fatty acid salt. Fatty acid salt, which is actually the soap, okay, plus glycerol. Okay, another example. Let's say I take instead of palmitic acid, if I take oleic acid, okay, oleic acid plus, let's say this time I use potassium hydroxide. So I use potassium hydroxide, okay, just to see what is the reaction which is going to occur. I got no space, so oleic acid plus potassium hydroxide is going to give us a salt which is called a fatty acid salt. That is the soap which we require. So here we take potassium and oleic. Okay, just now we took sodium and palmitic, so we get sodium palmitate. Now we take potassium and oleic, we will get potassium oleate. So you can see basically the IC, okay, the IC here and the IC here, palmitic and oleic is replaced with TATE, or here in this case TE. Okay, so that is what is going to be formed, and of course we have plus glycerol, right? These are two examples of soap that is forming. So this is the soap, sodium palmitate and potassium oleate. Okay, two kinds of soap. Okay, moving on. Now this is a simple experiment to prepare soap in laboratory. So same example, here we are using palm oil and sodium hydroxide. Okay, palm oil and sodium hydroxide. These are the two key components. Palm oil is the natural ester, and sodium hydroxide is basically the alkaline. Okay, when you mix these two, okay, and it's heated up, okay, it's heated, what we actually get is we are going to get a solidification, okay, a solid which will form. You have to stir it for some time as you heat it up. These two components, heat up and stir it, and as you do that, you got to add in this thing called sodium chloride. So sodium chloride is common salt, okay, sodium chloride is normal household salt. Now it's added to the mixture. The sodium chloride is an additional ingredient added to help the mixture to solidify faster. Okay, so the reason which we are using sodium chloride is to reduce the solubility of soap. That means to allow it to solidify. Okay, because we want to get soap, so we need the mixture to solidify. Okay, once we get the product, okay, some solids will form in here. We actually pour it through a filter paper, and the pieces which is collected here is the soap. In this case, the soap will have a chemical formula of, because we are using sodium hydroxide, so sodium palmitate. Okay, because palm oil and sodium hydroxide. So that is how soap is produced in the laboratory. Okay, next, last section, cleansing action of soap. Okay, for soap molecular structure, this is the molecular structure of soap. It has a head and it has a tail. All right, so the head part is called hydrophilic section, and the tail part is, okay, the tail part is called hydrophobic section. Okay, so as I said, the tail section here is called the hydrophobic section. Okay, so we got head hydrophilic. Hydrophilic means, okay, hydrophilic means like water. Okay, you can think of it this way. Hydrophilic means that section of the molecule in the soap likes water or attached to water, dissolves in water. Okay, hydrophobic section is it does not like water. Phobic means phobia. Okay, phobic means do not like, do not like water. Okay, so this part will dissolve in the grease or the dirt. All right. Okay, so remember, head is hydrophilic and tail is hydrophobic. Okay, so how it works? Let's see how it works, the cleaning action of soap. Now, first of all, let's say we got a grease in a piece of clothing. Okay, this is your clothes, and on top you got a grease or a dirt or anything, all right, oil stain or something. Now, when we mix soap into the water, okay, this soap contains this thing called soap molecules, which we know got a head and a tail. Okay, so the soap molecule, okay, which looks like this, all right, the tail part, okay, the tail part of the soap molecule, which is hydrophilic, okay, hydrophilic, will actually attach itself to the grease. Okay, sorry, the tail part, which is hydrophobic, okay, hydrophobic, will attach itself to the grease, and the head part, okay, the head part, which is hydrophilic, okay, hydrophilic, will attach itself to the water. So this part here is hydrophilic and the tail part is hydrophobic. Okay, so what happens here, eventually the water will pull the section which is hydrophilic. Okay, the head part is hydrophilic, will be pulled by the water. Okay, the hydrophilic part, the head, is pulled by the water, and that will cause the grease or the dirt to be pulled out from the clothing or the fabric. All right, so that is basically the cleaning action of soap. Okay, you can see it in the pictures here. So eventually the whole grease structure will be pulled out from the clothings. All right, so this is the end of soap. Please go through again this video, look through the video again. All right, any questions you can ask me on WhatsApp. Now I will be posting, after this I'll be posting a quiz which I want you to actually answer. It contains about 4 or 5 questions, okay, on the quiz. So the quiz alone, I need you to submit to me by WhatsApp, okay, in the group, or you can just send it to my WhatsApp, your answers. Okay, snap a picture, clear picture of your answer for the quiz, which I'll send to you after this, and send all your answers, okay, by today. All right, so latest by tomorrow. Okay, you got to submit that in, huh? Okay, and on top of that, I will also be giving you some additional practice. I'll post it in the group. So that's the end for today's video.